Hey guys, thanks for tuning in to another video on ForgottenWeapons.com. I'm Ian McCollum and I'm here today at the British Royal Armouries with a pair of very special guns. These are both Belton repeating flintlocks, and there's a fantastic, fascinating story behind them. Now, Joseph Belton was an American sailor and inventor who, we believe, came up with the concept embodied in these two guns. He worked with a British gunsmith by the name of William Jover, who actually manufactured his samples. Now, as far back as 1757, Belton was attempting to market a repeating firearm, and his early guns were essentially Roman candle guns. You may have seen something like this with the Chambers machine gun that I have a previous video on. The idea is essentially you load a powder charge and a projectile and a powder charge and a projectile, stacked all the way down, and there's a hole through the center of each projectile. So you ignite the powder charge at the front, and the flame burns through and fires off every projectile in succession, like a Roman candle. Belton had a system like this in the 1750s. And he wasn't able, as far as we can tell, to find any significant buyers for it, but he kept trying and he kept working on the system. In 1777, he actually demonstrated guns to the United States Congress. They knew about this. And at that point, he actually got a contract from the US Congress for 100 of these Roman candle firearms. They were, I believe, 8-shot in a single burst. And at that same time, he was also essentially trying to upsell them on a controlled, like a limited burst mechanism version, where you could actually interrupt the stack of cartridges with the occasional solid ball that didn't have the vent hole in it. You could actually reposition and recock the flintlock on the gun, and you could have actual bursts. You could have, say, 8 rounds loaded in the gun and fire them in 4 pairs. Bang, bang, to fire 2, recock it, bang, bang, fire another 2, and so on until you ran out of loaded ammunition. That's pretty cool, but what's really impressive is that Belton continued to work on these, and by the early mid-1780s, he had a system embodied here that was almost by every definition in the modern sense semi-automatic. This was a rifle that he advertised as being able to fire 21 rounds in 1 minute. And he was able to do that with 3 preloaded magazine tubes of 7 rounds each in a system where you would load and cock the flintlock mechanism, fire it once, click it once. You wouldn't then have to reload the flint. You could fire 6 more rounds within about a minute, as fast as you could pull the trigger, just like a modern semi-automatic. Now, 1784, Belton is pitching this system, in fact, to the British Board of Ordnance. He's looking for buyers wherever he can find them. The British Board of Ordnance tests this gun, but isn't interested in it. Almost the same year, in 1785, he submits it to the British East India Company, and the British East India Company is interested. Not only are they interested, they make a purchase with him. They purchase 560 guns of this type. 100 muskets like this, 160 shorter carbines, and 100 pairs of pistols, so 200 pistols, multi-shot repeating flintlock pistols. It is, I think, so far as I've seen, it is the best technological example of a pre-1800s repeating very easily, very fast firing repeating firearms. So let's take a closer look. Both of these examples that we have here have multiple firing modes. You could pick everything from fully semi-automatic, so to speak, down to single-shot muzzleloader, depending on what you needed at the time. So let me show you how they work. All right, the first gun we're going to look at here is the one that was tested by the British Ordnance Board. So we have, well, 7 triggers on this gun. The way this works, we have one flintlock mechanism. So to fire it, what you would do is first remove the magazine tube. We have a latch right here. We're going to lift that out of the way, and then I can push this up, lift it out of the gun. Now this is a reproduction magazine tube that was made in 1983 by one of the curators of the Royal Armouries, would have been the Pattern Room collection at the time. There are 7 touch holes in this magazine tube. So what you would do is load powder, ball, powder, ball, etc., all the way full, and you have a potential for 7 shots. These touch holes are rotated towards the lock. There is, by the way, a nested connection up here. That cone fits into that conical hole. And then at the back, this bar lines up the magazine tube in the proper orientation. Slide it in, lock it in place right there. Then our lock is lined up with the very first touch hole. Cock it, prime it. When you pull the trigger, it's a little hard to see here because it's located behind, but there is a trigger bar. Let's see, where can we show you this? There you go. You can see the trigger bar moving in the background there. If this lock were cocked, and I can't cock it because there is a broken spring inside it, that main trigger would fire the lock, which would go through the touch hole, fire off the round. Now, in a gun like this, you have solid projectiles. There are no vent holes between them. In theory, you could load this magazine tube up like a Roman candle and fire it off that way, but that wasn't the design intent here. The intent was after firing the first shot, you would recock the lock, you would reprime it, put the frizzen back down, and then you can use this trigger to pull the lock back to the next firing hole. If you look up close here, these triggers have little stop catches on them. The system doesn't work particularly well now. It's, well, it's very old and worn. But originally, when in proper new condition, each one of these triggers will pull the lock back until it is precisely aligned with one of the touch holes. So in this way, you have sort of the typical style of repeating flintlock, where yes, you can fire multiple shots without reloading, but you do have to recock and reprime the lock between each shot. But like that's still going to be a lot faster than loading each projectile manually from the muzzle. Now the East India Company gun is where things get really interesting. First, let me just point out here, we have our date of 1786. This is serial number 124 of the East India guns, and this is the crest, the logo of the British East India Company. This gun has a very similar magazine system. I can unlock the magazine tube here. I can lift this out. I have my 7 touch holes. This is again 7-shot capacity tube, and in theory you would carry spare tubes with you preloaded. You don't want water to get into these holes, but the front's going to be reasonably well sealed up as long as you take decent care of this. You have 7 shots ready to go as quickly as you can drop them into the gun. Now it's interesting to note on this gun we also have 5 screws set in the bottom of the magazine, and those match up with 5 screw holes in the bottom of the stock, which also match up with holes in the bottom of the action, well, going through the stock. And while it's not documented, it seems pretty likely, the obvious explanation here is that these are safety holes. Should something bad happen, should you accidentally somehow ignite a cartridge that's not the first one, or a projectile that's not the first one, you would in theory have like the gun would detonate and explode. If the barrel and system are strong enough, it will push out multiple projectiles, but otherwise it's like firing a round into a squib round. Well, the safety mechanism here is this is your weak point. This will blow out, which will then in turn blow out the screw in the bottom of the stock. You would hold it up here where there isn't one of these. And in case of a catastrophic malfunction, you have a safety mechanism to divert that energy safely, at least reasonably safely, more safely than having the whole gun explode in your face. A reasonable safety mechanism there. I really like this concept. This is a cool thing to see added to a gun like this. Now, to get back to how this works in fully semi-automatic, you have your loaded magazine tube here, and we're going to once again nest that into its front conical home, snap that back into place. Now, I have a little latch here that allows me to slide the lock to and fro on the action. So what I would do is slide this up to this front notch, which by the way I can't do because someone has repaired this stock. You can see a seam right there. They have done a beautiful job putting in replacement wood without understanding quite how the gun works, because the lock doesn't quite go far enough forward to get into the front position. But ignoring that, we'll put it to the second position right there. I load and prime the lock, and then I also have this little guy. This is connected to my second set of triggers here. So that pulls this thing back, and this is designed to hold what's called a portfire. It is a slow-burning fuse of the type that was very commonly used on cannons, the sort of thing that will burn at a rate of about 1 inch per minute. So on cannons, you'd have or on bombs, cannon fuses, you'd have a long string of it. For this, you would cut a short section about 1 inch long, put it in here. This has a little steel spring to hold it in place. And then this gets nestled up right next to our firing lock. You can see the touch hole right there through the frizzen. When you fire the first shot, it's going to put fire through the touch hole and fire the round, and it's also going to ignite that port fire. Now, you can leave the lock where it is, and you can use these secondary triggers here to slide the port fire back to the next touch hole incrementally. Now, there are, just like the previous gun, you can see there are little catches up here in the top of this bar, but the whole thing is really quite terribly worn, and those stops no longer work. But when this was originally in good new condition, this would kind of click into place at each touch hole. But that port fire is going to burn for about 60 seconds, and as you advance it to each successive touch hole, it will light off each successive round. Meaning you fire the first round with the lock, and then once this is burning, you can fire the next 6 rounds at any cadence you like, fast or slow, as long as this port fire remains burning. If, let's say, you fire 2 rounds and, well, then you don't have another opportunity, another target to shoot at, and the port fire burns all the way down and extinguishes, well, what you can do then is manually reset the lock to the first remaining live cartridge, recock it, set a new port fire in here, repeat the whole process, fire again, and for example, now we would have 1, 2, 3, 4 remaining cartridges, remaining projectiles to fire. So we can reset the process and finish off the rest of the magazine tube. If you don't want to deal with this at all, if you just want the equivalent of a magazine disconnect on a modern bolt-action rifle, you can simply not load anything into it, and you can manually reload, recock, and move this lock to fire each round in succession. If you want to, you can simply load 1 round at a time, like a traditional muzzleloader. There are guides here for a ramrod to load this 1 round at a time. Or you can go all the way to the other end of the spectrum, get yourself a stack of port fires and a whole bandolier full of fully loaded magazine tubes, and have a tremendous amount of firepower in a handheld weapon from 1786. It is kind of understandable that Belton didn't get a lot of contracts for these guns. They were very expensive at the time. It's a little bit difficult to convert currencies over significant historical periods, but he was his British East India order was approximately 2,250 pounds for 560 guns. So we're talking approximately 5 pounds per firearm. Now, converting that to modern dollars, depending on the method of conversion you use, you're looking at somewhere between like $3,000 and potentially $30,000 per firearm, which is not hugely out of the field of possibility if you look at what Maxim guns cost military forces early in their development, when they really were cutting-edge technology and the only substantial option for countries. You had similarly very expensive prices on them. There's a lot of work that went into them. There was a lot of intellectual property and exclusivity and potential battlefield advantage to these guns that made them worth a high price. But East India Company paid pretty dearly for these guns, and so would anyone else. The United States Congress in 1777, they committed to buying 100 of his Roman candle guns, but then there were price disputes, and the contract was never fulfilled. The guns were never built or delivered. And I can imagine the US government would have been pretty touchy about it at that point. They didn't have a ton of money to work with, and 100 Belton guns would have been a significant amount of money. Anyway, you may be wondering, how well did these work? And the answer is, we just don't know. We know that the 560 guns for the East India Company were completed. They were built in 1786. This is in fact one of that contract. It's dated 1786. And we have records showing that the company paid Belton and his collaborators the full price of the contract, which they can't imagine they would have done if the guns weren't all completed, because we also have documentation that they were loaded onto ships and sent to India. Now, apparently they just missed the window to get on the 1786 shipping season. They had to delay the guns to the next year. They were shipped out in 1787. Half of them were sent to Bengal and half of them were sent to Madras. And that's where the trail ends. We have paperwork that they were safely received in port, and then nothing else has shown up. So we don't have any reports on their use, on their efficacy, anything like that. The only survivor, the only later evidence we have of the guns is this example that came out of the British Royal United Services Museum in the 1960s, when it was moved to what is now the Royal Armouries collection and survives here. Unfortunately, we don't know where the United Services Museum picked it up. Possibly came back with a British officer or an Indian officer from India. We don't know. It would be fantastic to find some documentation of how these guns worked for the East India Company. One could assume that they didn't work very well because there were no subsequent orders. If they worked really well, one would think that this would have been a real game changer for a small group of people trying to exert dominance over a very large group of people. On the other hand, they were extremely expensive guns, and perhaps they worked, but turned out that level of firepower just wasn't necessary and wasn't cost effective, and that's why they weren't ordered. Unfortunately, we just don't know. Either way, these are amazing examples of legitimate, like technologically advanced repeating firepower as early as the 1780s, which is fantastic to see. So I'd like to give a big thanks to the British Royal Armouries for giving me access to these two priceless examples to film for you guys. I really hope you enjoyed the video. Thanks for watching.